Hello and welcome to today's video. In today's video, we are going to learn about ionic equations. So before we define ionic equations, there is a prerequisite background that we're supposed to have with regards to this particular topic. So for us to have a comprehensive understanding of ionic equations, we are supposed to have a very good background on one, I'll just say chemical equations. And then we're also supposed to have a solid foundation on balancing of chemical equations. Okay, now we can go straight into the lesson for today. So what is an ionic equation? So basically an ionic equation is just an expression of an equation using ions. So it shows the ions present. It tells us the ions present in a given solution. Right, so what are some of the key important things that we're supposed to take note of when we are dealing with an ionic equation? So we have what we call, say, the steps. So the first thing that we're supposed to pay attention to is, first, we have to know how to write a chemical equation. If we can write a chemical equation, then secondly, we have to balance the chemical equation. If we can balance the chemical equation, then it takes us to the third step. So on the third step, we have to know how to dissociate. We can dissociate compounds in aqueous state only. So this is very important. So only compounds in aqueous state are supposed to be dissociated. And I'm going to give examples of what this means. And then what follows after this is we can now cancel what we call spectator ions. What are spectator ions? So spectator ions, we say these are ions that appear on both the reactant and product side. We're going to give more examples. Then finally we can write a net ionic equation. So what is a net ionic equation? So this is an equation that shows the ions present in the solution or in the given equation. Okay, let's look at what we call dissociation. dissociation of ions. Sorry, dissociation of compounds. So I'm just going to give very simple examples. So one, we can look at dissociation of HCl. So when HCl dissociates, we're going to get H positive and Cl negative. So remember, all acids are in aqueous state. So we're going to have something like this. If we give an example of sulfuric acid, when this dissociates, so we get H positive and SO4 to negative. Now remember, we have to balance the equation. So to balance the equation, we put a 2 there. Let's give an example of sodium hydroxide. When this dissociates, we have this in aqueous state. So all these are aqueous, as OH minus and aqueous. So dissociation is just a decomposition of a compound. I always give this example. So before it was sulfuric acid, it was hydrogen combining with a sulfate. So the valence number is 1, the valence number is 2. And then when you combine, you get H2SO4. So when you take it back, you reverse, you do a reverse of it, you do a reverse, then that one is negative, that one is positive. So the same thing, if we are looking at sodium hydroxide, it was sodium combining with this, so this is 1 and 1 equivalences, obviously, and then it becomes sodium hydroxide. So when you reverse, this is negative, that is positive. Let's look at a more interesting example. Let's say we have sodium sulfate as aqueous. So this is the same thing. So sodium sulfate, this is 1, this is 2. So when you interchange, it gives you sodium sulfate. When you reverse, so that is negative, this is positive. So it's Na positive aqueous, then plus SO4 to negative aqueous. Then to balance the equation, obviously you put a 2 there. Now, let's look at an example of how to write an ionic equation. How to write an ionic equation. So following the steps that we were given. So the first step, let's say we are given an equation already. Sodium hydroxide in aqueous state. We have HCl in aqueous state, and this gives us sodium chloride in aqueous state, and H2O in liquid state. So here, when we look at this equation, the first question we'll ask ourselves is it balanced? So when we look at this is a balanced equation. So the equation is balanced, you tick. Then what follows next is dissociation. Dissociation. So only compounds in aqueous state. So remember, when you dissociate sodium hydroxide, when you dissociate sodium hydroxide, remember we got something like this. So when this is dissociated, you get Na positive aqueous plus OH negative aqueous. Then plus, when we dissociate, allow me to use different colors. When you dissociate hydrochloric acid, when we go back, it's here. So dissociation of hydrochloric acid will give us H positive aqueous plus Cl negative aqueous. Then sodium chloride, we didn't give any example, but obviously following the same principle, when we dissociate sodium chloride, we're going to get Na positive aqueous plus Cl negative aqueous. Then plus, so water is in liquid state, so we're not going to do anything. So it's H2O, then liquid. So we satisfy this. Then the second step, so this is an ionic equation, but for us to write what we call a net ionic equation, we have to identify what we call spectator ions. So these are ions that are appearing on both sides, and then we cancel them. So when we look at the equation here, we realize that sodium is appearing on both sides, then chloride is appearing on both sides. Therefore, what remains as the final equation becomes OH negative aqueous plus H positive aqueous, then H2O liquid. So this becomes the final net equation for this particular example. Let's look at another example, which we're going to call as example number 2. Let's say magnesium sulfate aqueous plus sodium nitrate aqueous. So this is a double displacement. So we're going to get sodium sulfate aqueous plus magnesium okay, let me use let me give you another example. This is not going to work out. Okay, let's look at sodium sulfate plus barium nitrate aqueous, then this will give us barium sulfate solid, then sodium nitrate aqueous. So to balance this equation, we just put a 2 right in front. All right, so when we start the dissociation, so the dissociation of this will give us 2Na positive aqueous and SO4 2 negative aqueous, plus this will be barium 2 positive aqueous plus 2 nitrate negative aqueous. Then this is a solid, you're not going to do anything, remains barium sulfate as a solid. Then this becomes 2Na positive. Remember, there's a coefficient in front, so we have to be mindful. Then 2NO3 negative aqueous. So from here, we're able to see that we have spectator ions, which is sodium, then nitrate. So the final becomes Ba2 positive aqueous as SO4 2 negative aqueous, giving us BaSO4 solid. So that becomes the final net equation. Let's look at another example. Let's say ammonium chloride aqueous reacts with sodium hydroxide, which is aqueous, then this would give us sodium chloride aqueous plus NH3 gas plus H2O liquid. So here we have to check if the equation is balanced, and the equation is already balanced. So the next thing that we have to do is dissociate the compounds in aqueous state. So if I dissociate this, I should have NH4 positive aqueous plus Cl negative aqueous. Then this becomes sodium Na positive aqueous plus OH negative aqueous. This is becomes that aqueous, then plus Cl negative aqueous. Then the NH3 remains the same and the H2O remains the same. Then you identify the spectator ions. So spectator ions, in this case, we have sodium and sodium, we have chloride and chloride. That's all. So the final equation becomes NH4 positive aqueous plus OH negative aqueous, giving us NH3 gas plus H2O liquid. And that becomes the final answer. See you in the next video.